The handle of this titanium mug was joined to the body by welding. At the welding temperature, titanium reacts with oxygen in the air, forming an oxide. The oxide makes the weld more brittle. Chemical properties such as reactivity depend on an element's electron configuration. When is an atom unlikely to react? When the highest occupied energy level of an atom is filled with electrons, the atom is stable and not likely to react. Stable electron configurations. The chemical properties of an element depend on the number of valence electrons. An electron dot diagram is a model of an atom in which each dot represents a valence electron. The symbol in the center represents the nucleus and all the other electrons in the atom. Electron dot diagrams for some group A elements. Group 1A, Group 2A, Group 3A, Group 4A, Group 5A, Group 6A, Group 7A, and Group 8A. Noble gases are the most stable elements. The highest occupied energy level of a noble gas atom is completely filled. The noble gases have stable electron configurations with 8 valence electrons, 2 electrons in the case of helium. Elements tend to react to achieve electron configurations similar to those of noble gases. Ionic bonds. What is one way in which elements can achieve stable electron configurations? Some elements achieve stable electron configurations through the transfer of electrons between atoms. Transfer of electrons. A chlorine atom has 1 electron fewer than an argon atom. Adding 1 electron would give chlorine a stable configuration. A sodium atom has 1 more electron than a neon atom. Removing 1 electron will give sodium a stable configuration. When sodium reacts with chlorine, an electron is transferred from each sodium atom to a chlorine atom. Each atom ends up with a more stable electron arrangement than it had before the transfer. Formation of ions. When an atom gains or loses an electron, the number of protons is no longer equal to the number of electrons. The charge of the atom is not balanced, and the atom is not neutral. An atom that has a net positive or negative electric charge is called an ion. The charge on an ion is represented by a plus or a minus sign. The ion that forms when a chlorine atom gains an electron has 17 protons and 18 electrons. This ion has a charge of 1 negative. The symbol for the ion is written Cl1 negative or Cl negative for short. An ion with a negative charge is an anion. Anions, like the Cl negative ion, are named by using part of the element name plus the suffix "-ide". Thus, Cl negative is called a chloride ion. A sodium ion has 11 protons and 10 electrons. The sodium ion has a charge of 1 positive. The symbol for the ion is written Na1 plus or Na positive for short. An ion with a positive charge is called a cation. A cation uses the element name as in the sodium ion. Scientists use atomic radii to compare the sizes of atoms of different elements. The radius of a sphere is the difference from the center of the sphere to its outer edge, half the diameter of the sphere. Atomic radii are extremely small. They are expressed in units of picometers. There are 1 billion, or 10 to the 9th, picometers in a millimeter. This table shows the atomic radius and ionic radius for 6 metals and 6 nonmetals. You use the data to relate the size of an element's atoms to the element's location on the periodic table, and to compare the sizes of atoms and their ions. Using tables within a period, what happens to the atomic radius as the atomic number of the elements increases? Within a period, the atomic radius decreases as the atomic number increases. Using tables within groups 1A, 2A, 6A, and 7A, what happens to the atomic radius of elements as the atomic number increases? Within these groups, the atomic radius increases as the atomic number increases. How does adding an occupied energy level affect the atomic radius? Hint: lithium is a period 2 element, and sodium is a period 3 element. When the next higher energy level is occupied, there is a significant increase in atomic radius. Compare the atomic and ionic radii for potassium and for bromine. The ionic radius for potassium is much smaller than its atomic radius. The ionic radius for bromine is much larger than its atomic radius. What happens to the radius of an atom when the atom loses electrons? When the atom gains electrons? With the loss of valence electrons, the radius decreases. With the addition of valence electrons, the radius increases. Explain the difference in size between a metal atom and its cation. An energy level that was occupied is no longer occupied, and the size decreases. A particle with a negative charge will attract a particle with a positive charge. A chemical bond is the force that holds atoms or ions together as a unit. An ionic bond is the force that holds cations and anions together. And an ionic bond forms when electrons are transferred from one atom to another. Cations form when electrons gain enough energy to escape from atoms. The energy allows electrons to overcome the attraction of the protons in the nucleus. The amount of energy used to remove an electron is called ionization energy. The lower the ionization energy, the easier it is to remove an electron from an atom. This figure shows two trends for ionization energy. As you move from left to right on the periodic table, the energy required to remove an electron generally increases. And if you're looking at the group 1A alkali metals, the energy required to remove an electron generally decreases. How does the structure of an ionic compound affect its properties? Solids whose particles are arranged in a lattice structure are called crystals. The properties of an ionic compound can be explained by the strong attractions among ions within a crystal lattice. Compounds that contain ionic bonds are ionic compounds, which can be represented by chemical formulas. A chemical formula is a notation that shows what elements a compound contains and the ratio of the atoms or ions of those elements in the compound. The chemical formula for sodium chloride, NaCl, indicates one sodium ion for each chloride atom in sodium chloride. What is the chemical formula for magnesium chloride? A magnesium atom cannot reach a stable electron configuration by reacting with just one chlorine atom. It must transfer electrons to two chlorine atoms. After the transfer, the charge on the magnesium ion is 2 positive, and its symbol is magnesium 2 positive. The formula for magnesium chloride is MgCl2. The 2 written to the right, slightly below the symbol for chlorine, is used to show the relative numbers of atoms of the elements present. Magnesium chloride is used to control dust on unpaved roads. Crystal lattices. The chemical formula for an ionic compound tells you the ratio of the ions in the compound, but not how the ions are arranged. If you look at a sample of sodium chloride with a hand lens or microscope, you will be able to see that the pieces of salt are shaped like cubes. The crystal shape is a clue to how the sodium and chloride ions are arranged in the compound. Ions in sodium chloride are arranged in an orderly three-dimensional structure. Each chloride ion is surrounded by 6 sodium ions, and each sodium ion is surrounded by 6 chloride ions. Each ion is attracted to all the neighboring ions with an opposite charge. This set of attraction keeps the ions in fixed positions in a rigid framework or lattice. The structure and shape of a crystal are related. In Figure A, in a sodium chloride crystal, each ion is surrounded by 6 oppositely charged ions. In Figure B, sodium chloride crystals are shaped like cubes. The shape of an ionic crystal, for example, the cubic shape of a sodium chloride crystal, depends on the arrangement of ions in its lattice. The arrangement of the ions depends on the ratio of ions and their relative sizes. Crystals are classified into groups based on the shape of their crystals. Properties of ionic compounds. The properties of sodium chloride are typical of ionic compounds. Sodium chloride has a high melting point, 801 degrees Celsius. Solid sodium chloride is a poor conductor of electric current. When melted, it is a good conductor of electric current. Sodium chloride crystals shatter when struck with a hammer. The arrangement of particles in a substance is the result of 2 opposing factors: the attractions among particles in the substance and the kinetic energy of the particles. The stronger the attractions among the particles, the more kinetic energy the particles must have before they can separate. Ionic compounds have strong attractions between particles and high melting points. For an electric current to flow, charged particles must be able to move from one location to another. Ions in a solid crystal lattice have fixed positions. Solid sodium chloride is a poor conductor of electric current. When the solid melts, the lattice breaks apart and the ions are free to flow. Molten sodium chloride is an excellent conductor of electric current. When an ionic crystal is struck, ions are moved from their fixed positions. Ions with the same charge repel one another and the crystal shatters.